Hello, welcome back. So today I'm going to be continuing to work on Kano script, right here. So today I want to work on basically getting it so that we have more types. Because right now we're a bit limited in terms of the types that we have. So I went over this on the last stream. Right. So the only single byte type that we have is a character, and I can actually go to the source and then I can go to the demonstrator, right? So we can see all the data types here. So we have integers, pointers. Right. So these are 64-bit integers, so they're 8 bytes, right? The pointers are 8 bytes as well, because this is 64-bit machine. Void, that is nothing, right? That is not really technically a type. It's like an empty type, right? Um, Character. We have a character, and that's a single byte. This is an 8 byte. It's really a double. I call it a float, even though it's really a double, so I'll probably change that. And then I don't know why we have another pointer. Why is there two pointers? That is very strange. I don't know actually. And let me go to the in here. We have the type. Type pointer. Oh, okay, because one of them is a string, right? So that is why actually. So maybe I'll even change that first one to a char star. That would make sense probably. Anyway, basically that's what we've got. So I really need to change that on level of the virtual machine first. Because if we go to the union here, right? All the data types that we have integer, float, character, pointer, and then we also have this register type. Don't worry about that because that is unused and I need to get rid of it. I just have not yet. And also top type, I don't remember what that's for, but I do not think it's used. So these really are what we have, the words here. So we have like as int, as float, as character, as pointer, and then we can add the rest from there. So I think what I'd like to do, I change this to int64t, right, as int. And then change this to float as well. Yeah, I think. Yeah, so that should actually no, 32. That's right. That should still compile, I believe. Maybe not. Okay, yeah, because now we have this. It's trying to print stuff out where we are printing it. So let's search for where we have LD, right? Can I do that? LD. Yes, we have a few of these places. Let's see. Does that? Almost fixed it. So then as int is that, but okay. Yeah, so I use this macro here, so that makes it work cross-platform. I can get rid of that now and just hit 2%d again. That's on 1160. Right, that's I think it's in standard int or something like that. And that is UN64T. And where is that at actually? 736. That is interesting. So the value, okay. Why do I use that here when it's not an unsigned integer? So I'm not sure. I'm gonna need to right. So in type, yeah. If we make this that right, then that's gonna work better. The types are a little messed up on the syntax highlighting. Don't worry about that. Yeah. So we switch over the types here, and this is when we're disassembling it. Yeah. So we're gonna need to do some stuff for that. But we do have that. Perhaps I'll even make this just in 64T, and then do that. Because right, it casts it, but it should still work. And then here we have the same thing, right? So 588. We look at that. We can just do the same thing here as well. Okay. And there seems to be another thing in 32T. Okay, yeah, it's just a regular integer. I'm still gonna stick with that because it's very clear what the type is, right? We have, yeah, okay, yet another one. I guess it just fails on this one, so maybe I could even search for that. Prid, if I just put prid, come on. Prid. I guess that's it. It's like print the decimal integer, right? If I run it, should still all work, right? Maybe not. What does it say vaulting before? Let's see. Let's get rid of the hide cursor then. And right, I don't know why it would say fault now. That is very strange. Let me look in GDB. I'm quite certain it was not before, but I guess it could have been. Can I see where it fails? It seems to be perhaps stuck in a loop. Let's close all that. Quit. Yes. And let me open this and try to maybe, right, reduce this down a bit. I can read the keys, and I just want this, yeah? Maybe make a... Alright, let me actually change it back, right? So it's gonna give some errors, but that's fine. Change it back to a 64. And I don't think we used the float, so I'm gonna leave that. I want to sort of track down what is causing it. Like, I'm pretty sure it was from the change because it was working yesterday as I did. Okay, we get errors for it. Yeah, so I can't just do that. So that's a bit unfortunate. But if I change the make file and I get rid of W error, I think it will still compile. You know, it just yeah, now we have zero. So it should still compile. And yes, okay, so it is with that. It's okay, which one of these would is something expecting a 64-bit integer? Ooh, perhaps. Well, no, that shouldn't be. That should be a single 32-bit one. So I don't know. That's a bit interesting. Yeah, I'm not sure what would, you know? Because I'm pretty sure all of these just accept regular integers. And it wasn't the floats, obviously, because we're not using floats here, so... Yeah, I don't know. Perhaps it could be... Oh, you know what? It's because we didn't change the type sizes. That could definitely be. So let's change this back. Right, so 32. That'll get rid of all the warning as well. But then we go into, I think we have the type sizes. Which one is it in? Probably in... Yeah, right here. So, no, that's not it. What's it back here? I don't know. It's somewhere around here where we have the... Oh, yeah, right here. Okay. So, type size. So this will be 4 now. And then, 4 for the float as well. I'm pretty sure size of float. Let me actually make sure. So let me make just a probe, right? And then I'll just do this. And print F. So I just want to print the size of... Right, that could probably just be a regular integer, but size of float, right? Something I don't know why I froze for a second. Okay, yeah, and then double. Right, it should be a double float, so it's gonna be twice the size, right? Yeah, okay. So that that does work out. As I expected, right? So let me go up here and dash R. I just wanted to make sure that I clicked on that. So build that and go here, and it still does not fix the issue, so that's interesting. I don't think there's another place where we set the sizes. So it could be something else, you know? Something else that is causing that. Or I need to save it, perhaps. Could be that. Okay, so it is not just that. There's gonna be other things as well. Could this be... Right, I'm just, you know... Let me go down here, right? Not there necessarily, but when we're setting this up, we actually set the types based on that. So that is interesting. Well, we don't, I guess. The return type. Where do we set that? Yeah, result. So we do that here. To as it. Yeah, so it sets it to an int already, rather than an int64t. So that is interesting. An interesting thought, right? Pointer. Not sure. Okay, well, could it be? Actually, that is probably it. User include. Right here. We don't actually, oh shoot, okay, it looks kind of weird. But I did not update it here. Now, I wonder, that's probably going to cause a lot of warnings. If I run that, it still cycles, okay. wonder if this failed to compile now. Right, because we basically include the whole thing here, which temporary, right? I want to embed what we need into the actual file, but for now it's just easier to do it like this, right? Oh, that's kind of why I do that. There is. Okay, maybe that was not it. I don't know if I want to change it back though. Right, maybe maybe I don't need to worry about this yet. You know, where is? Where is it? Did I mess something up? Right, like all that was not there before, right? Oh, okay, because that is the string view stuff. All right, that is correct. Yeah, let's just go here and let's change back to 64. Run that, and you know, it's still not gonna work. I'm gonna change it back. So I'll have the go back to .h. All right, well actually I need to make sure it is the same in here. So we'll change it back to 8. I'll leave that as 4. I think that's fine. So then we'll have a double type as well, which will replace the previous flow type, which is, you know, which will be correct in that case. Let's go here and let's add the rest of them. I'll change back. I would like to eventually have it be 32-bit integer is the standard integer, but for now we don't need that, right? Well, maybe not even, since right, we're storing it in the union anyway, so it takes up that amount of bytes. So maybe the default one should be the maximum size. So maybe that even makes sense in the first place. But we can make double as that anyway. And we do need to add those up here as well. So that goes after the float. These aren't in the same order, and that is, well, they are, okay. Double type. Okay, and then, so this is in types. That is the standard in type. That'll be the initial one. Then we'll have, 8t as u8. And then, let's see. Let's do that, and let's do as u16, u32, and I'll just probably implement the unsigned ones for now because we don't even actually have a way of working with unsigned or with signed integers like negative numbers, right? Because those are not supported by the Lexer. Okay, I seem to have, yeah. So I'll worry about that for now. So let's do u8. Oops, that's not right. Don't need to set it equal to 0 though. Okay. I am a little... Okay, and there we go. And 64. Okay, so that should cover it. Let me make sure that still compiles. That is not what I meant to do. It actually compile like that. So it shouldn't cause any failures. What is this? Okay, yeah, because now we have to change all of that stuff back. Right, so I'm just going to change it to LD for now. Right, so it's not going to work on, like, I think macOS, it has the wrong thing and stuff like that. It's not that big of a deal, though. Alright, I think that's it. Okay, and then it does compile, so that is good. So now we need to actually handle it, though. Because we have the types, we don't have a way to actually utilize them, right? So let's do maybe push. So standard in type is in 64, right? So case of in type, we do this. So we pop off in 64t. This is actually the dissymbol. So let's go to, I want to go to push, right? So we switch over the types and we push based on that. So I think maybe it would just work, right? If we implement it in the virtual machine or in the compiler, given the proper types, it should work. The thing is, right, if we go to say inst add, right, we have these. So we have all the different types. And interprets them as int. Right. So we want to switch over the types and interpret them properly. Can we do or we have math operator. We pass the things. Is there a way, right? So if we pass the actual type there, would that work? But I'm trying to think of a way to make it less, right? So easier. So as, and then, well, we don't really have that, do we? Right, because this interprets as flow, so that way we can do addition on that. So I think the issue yesterday that we're having had to do with the compare, you know? So if we switch over it, yeah, we compare the characters as that type based on which one. So the first one that we pop off. So based on the first one that we pop off. So if we're doing that, it might have been right triggering this compare rather than this compare, and that is why that was working better, right? But yeah, so we could probably interpret all of the integers, and well, not the unsigned. Well, okay, the unsigned ones wouldn't necessarily work as that. But if we interpret any unsigned integers the same way, it would probably work out as the U64, right? So let's maybe do, what is this? Why do we have that, right? Why does it have to be an integer? But if we do type, I don't remember what it's called. Let me look here. Yeah, data type. Why do I didn't use underscore. It's a different type. It's a different yeah. Anyway, so data type without underscore. I don't like that. Don't have to cast it to an int, but then we have the type. And then we can use this instead. So this can be type int, or is it int type? Again, I do not remember. So type, not int, int type. It is int type. Okay, that is good to know. Int type. Okay. Have an extra space there, and then this will be type char type, which really do even need a char type. I'm not sure. It's a type. And actually, I think it is PTR type, and it'll tell us if we're wrong, but I'm pretty sure it is. So then we have some other ones here, right? So now we can have right. So I need to really do these for all of these. So I could probably make a macro to fill this out. A macro which calls a macro, which I'm not sure if that's a good idea, but we'll see. So this will be U8. Well, okay. You can compare it all as U64, right? U8 type, U16 type, and I'm pretty sure that will still work, right? It would just basically implicitly cast. Well, let me actually try that out in a U. I want to make sure it will work. Yeah. See, so let's include ADIO main, and let's see. So we need a union. Let's do it. So we'll use type def as well, and this will be stop. Sure. So we'll have 8t as u8, and then we'll have uint 64t as 64. There we go. Need to include extended int. What I'll do is I'll create a stub, and then this is the val equals as u64. We'll do as u8 equals 16, right? So if we do that, and then we printf, and we print out the value, that's really a size type, right? So we can print it out like that. We can print val.as u64. I'll print that out. Hopefully it will work. $16. Alright, it does look like it will work. There's a null character that got inserted there. And let's maybe make another one, so we'll make u32 even. As u32, and let's make it 500, 100,100, right? And then we do that. Okay, so it looks like that's going to work out. That should work out fine. Okay, so that should work. That should be fine. So we can compare it as u64 equal to. Okay. 32 and 64. That should be fine. That should be fine. And then if we just add this to all of them, then we should be fine. So it on F. Oh shoot, we have all these for floats as well. I forgot about that. But I don't really use them, and I want to get rid of them because they can just be replaced by the single add and switch over, you know? That was before we had an enum for the types, right? Let me do it like that. Let's see, that should still compile, hopefully. Double type, yeah, so double type, so we need to add that. That is fine. So I think we can do more or less the same thing here. Well, okay, it might not work quite as well. But for now, I'm just gonna do it like that. Okay, and there might be another one. Okay, so yeah, we have the default, and let's default and search false. Right, so we shouldn't hit this point. That means I do something improperly or whatever. Okay, and that covers that. Sets covers all that. So, if I add it now, it's it there, and let's see. I should be able to try it out. Like make some tests and try it out. Let's go here, and let's actually add some more types. We'll start here. So type. So we have that, and then we'll have right. I don't know that I want to. I think I want to append. Just so that the other ones will become more clear, right? So we have type U8, type U16, type U32, type U64, and then I guess just add type back there, and it should be fine. And then in the front end, we have to add all of those as well. So actually, let me go here and grab that. Grab this enum so I can compare it, right? Compare it with that to make sure I put them all in the correct place and whatnot. So, do I need to? Yeah, I shouldn't need to. Okay, so we have those, and this is gonna be the name that they appear as, right? So you'll have U8, and that's how it's gonna be. So you'll do word U8 equals 16, right? Like that. And I need to like the literals, I'm not sure what their value should be. It should probably just be like U64 or something, and then it would get casted, you know? So this will be U16, that's not U32, and 64. So 3, they are all 3 except for this one is 2. And then float and double. 1, 2, 3, 4, 5, 6. Okay, and that should work out. That's the length so that we can compare the size, right? Okay. Could probably make a macro for this as well, which basically you do like stir view, then you pass in what you want there, and it will expand into this. And then we'll use size of -1, but I'm not gonna do that for now, so that's fine. But that would make this look a lot nicer and make it easier to expand. But for now, it should be okay. So that, and then I think we should just need to add it here, you know? So I don't think we have it. Yeah, we don't have a copy one, but I do remember how it was. So we have int 8t, int 16t. Actually, I don't think we do that because I don't think it's used. It might be though, so that might cause some issues. But let's do it like this. U32 and one more U64. Okay, and also we need a double, so double is gonna be correct. And then right here we have these as well. I messed it up a little bit. There's some extra white space, which I think I'm probably gonna start using like a format, like Clank format or something, and I think that would basically clean up the files automatically. And it would probably make it more consistent, you know, because I'm not super consistent, unfortunately. U8, 16, U60, no, U32, and U64. Okay. Float and double. Okay. So let's see, and then we need to add the sizes here. So there's a few places that we have to change. And the sizes maybe could even be configured with a macro. Anyway, I'm not gonna worry about that for now, right? So I'm thinking like you could have a macro that sort of grabs these and takes like the size of them, something like that, but I'm not sure. Let's see. So at the end, so right, we'll have 1, 4, 1, 2, 4, and 8, and then we also have float and double. There we go. And let's try to compile that. Will it compile? Let's compile. We'll make a test.kno file, and let's do val u8 equals 32, and exit with that. Will that work? Not GCC. No, main test.kno. Right, so there's some null bytes, quite a few of them. Why was there so many? One there. What was the other one? 39? Okay, I'm not sure. Expression does not match the type of the var value. Oh, okay, you know what? We need to update the types in the expressions, because they return types there. Sorry about that. So let's do parse primary. And yeah, so we have this. So let's look at this. How is that going to work? Let's see. So the data type is type int. Right, so if any of the types are integer types, then it's really fine. As long as it's not an unsigned one or whatever, right? But let's see. So the expression does not match. Expression does. It's not match that. Yeah, so we check that here basically. It's basically just one of these. I'll maybe do this even so I can see it better. Right, so we check the non-equal stir because there's some issues with that, which I need to work on. So how do I want to check that really? Because really, they're fine. If I had an integer max value for all the integers, right? We could check as well and just make sure it's not greater than that. So, but I don't know. I'm not sure exactly. Let's maybe, let's see. Expression does. Right, is there more places we check? This is the only one. So, alright, is that really? I suppose so. So, let's do data is not equal. Right, so do check it here as well. And in here. Okay, so there is a few places. And there. Okay, so there is quite a few. So we should probably make a function to check that. Right, so make like basically type valid types, something like that, right? So maybe we'll put it even towards the top. That will return a boolean. That's the keyword is, that's fine. Boolean is valid. These valid types. I'm gonna take type oops, type 1 and then type 2. What we'll do is if type 1 is not equal type 2 and right, so there's gonna be a lot of conditions that we have to check here. So and type 1 is not equal type stir and type 2 does not equal type stir. Well, okay. Let's see. It's gonna just be way too long of a chain to do it like this. So could we loop over it even? We do have type count, so we could loop over it. Loop over and check them. I'm trying to think, like, so it'd be nice if there was a way to check that they're all integer types. But perhaps. Right, so it starts there. Starts at U8. So if it's greater than U8, if it equals that, or it's greater than U8, then they are fine. So let's do valid. Yeah, so, and that. So we check all those, and then we have, and, type 1, type in, this needs to be like this, or type 1 is greater than or equal to type 8, and type 2 equals type 8, or type 1 is greater than or equal to type U8, then that's the end there. So we can do that, and open this, here it is. So if that is the case, let's do this. If that, and that, and that. So if type 1 equals type 2, or either of them equal typester, or this is the case, then we will return true. Otherwise, we'll return false. And this could also be just return this expression, but I don't want to do that. So is valid type. So then we can do expression does. Yes, we can do that, and instead of this, we can do if these valid types. We pass node.value.var.value.data 0 data type and node.value.var.type this and that. Right. Basically just counting it out. And let's see, will that compile? Should it? Okay. Yeah, we need to wrap that as well. That makes sense, actually. I don't know why he thinks there's a comment, though. That's kind of strange. Actually, I think it's just... yeah, it's a little messed up. That's fine. Let's see. So that should work better, though. And if we do it... I'll run test.game. And it did... Okay, it looks like it did work. And that's not right. And let's make val use 16 equals 32. And then we'll exit with do val 2. If val equals val 2. I don't know if we can have, I don't know if that's even supported now I'm thinking about it. Yeah, okay, so that's another place that we have to check, right? So we can sort of go through this. Expression types. There is valid types. Inside data type and left hand side data type. And that's it. Okay, and then that should work, right? So sort of step 8, you know? And I messed that up. I am missing a closing. There we go. Okay. Expression. That's not right. Expression with. Okay, that doesn't seem to have worked. It does recognize the type, so that is good. Good to know. But yeah, it doesn't seem to work. Let me perhaps like this again. See it better. Okay, that's not right. What if we go like this? Okay, so we can see it better. So it did not work. That's not game. If I change that, I just want to make sure that is the same location. Yeah, okay, so it is. It is indeed. So it is here where it's failing. So it is valid types. So why does that not work? So if type 1 equals type 2, or, right, the string, or type 1 equals type int, or it is greater than or equal to use u8, and type 2 equals type int, or that. So, or if they're both int, right? So I don't know what that is, what the issue is. Which one of these is false? Print out both of the values as their integer types, and see what the issue is then. 0 and 0, okay. That's the wrong one. Alright, 0, wait, what? Alright, 8 and 7 is where we are failing, right? So 8 and 7. So, why is it, are they in the wrong order? Right, so why is, am I printing it out wrong? Hang on, let me go back here. Valid. Type 1. I see it like this, left hand side and right hand side. So it's the same as the, how it is printed out. Alright, 7 and 8. Okay. And why is that valid? Right, so we know that that is a U8. Alright, let's see. So we know they are not equal, so this fails. Or neither of them are type stir, so that fails. Or this whole expression here. So type 1 equals type n, which is wrong. Or type 1 is greater than or equal to u8, and we know that is the case because type 1 is actually a u8, so it is equal to it. So this becomes true, and this has to be true. Type 2 is also going to be greater than or equal. Let me print out. Greater than or equal to type u8. Type 2 is greater than or equal to type u8. And let's see. 1 and 1. So they're both true. Wait, what? So did I do this expression wrong? 7 types. True and true. True and true. If I print out this this whole expression itself. Can I do that? Since we have too many, and that's fine. 1. So the expression is true. What the heck? True. It really prints out true. True. It is correct. Okay, but then the other times it is false. So these valid types. Oh shoot, I'm doing it the wrong way. If not is valid types. Okay, I'm stupid. So right, so if it's not valid, print out. Okay. But why did the other one succeed, right? So what is that about? Does not match the type of var val. Right, so it doesn't like that. So why does that fail now? So that is interesting. So I was doing it the wrong way. That makes sense. But so why is this false? So let me print out the types again. Type 1, type 2, and we'll take a look at what they are. So it should be type int and then type in, which is 0. Type 1 equals type int, which should be 0. Let me print out type and just make sure. Int is indeed 0, so that is fine. So it equals type in. Type 1 equals type in. And then type 2 is that. So why is it failing? Why is it failing? If I print this out, right? Type int or type 1 is greater than 8. So that's an OR condition. So I don't know why it would fail. If either of the conditions are true, that is true. But then this one is not now. 7, which we know is U8. So 2 to type U8. That is true as well. What the heck? So that is false. So what? False. So they are not valid types. If not is valid types. So if they're invalid, then print the expression does not match that. False. Even though they're both true. And that does mess stuff up, but that's fine. Type 2 is type, or type 2 is greater than or equal to that, right? So that should be what it comes down to. And they're both true, but okay, so something else is messed up. if this or this one. All of them are or. Type 1 does not equal type 2, so that is false. Or type 1 equals type stir, which is false. Or type 2 equals type stir, which is false. Or true condition, right? If I print out this condition, it is true. I grab just that condition, put it there, print it out. And there is the extra one now because of the ink, that's fine. And yes, it is only one condition. Zero. Okay, so why is that 0? Is it because of how they are wrapped? Type 1 equals type in. That is true. So already, that's true. So I have a true condition and another true condition. I see what it is right here. Type 2. I put type 1 twice. Okay. Now it will be true. That was really stupid. Okay. Echo that, and it does output with 1. Alright, okay, so that was just a very stupid mistake. That's my bad. Let's go here, make main test.kano. Echo that, and it does output as true. So we can compare them, so that all works. We have U8 and U16. So there is a few more places we'll have to check. So, type. Expected type. Expected type that, but found type that. So let's do if, if not is valid types. So this is with the external function call. Okay, so expert. What do we do before I build this? Let's run .kano. It's kano.kano, right? Does it compile again? Expected type pointer. Okay. Expected type pointer. Is that in the expected type? Right, maybe it's not in there. I'm not sure. I don't remember where it was at exactly, but we'll get to that. So expert data type and func r is not data I. Then do that. Okay, and then type equal. Okay, this one is that can be fine. This is for what? Function call. So that's an empty one, and this is okay. So this, yeah, that's gonna be the same thing. So not is valid types that and that one. Okay, and let me make sure that all compiles. Okay, it does. Data type. Alright, so that is just checking specifically type pointers, that's fine. And that is one that we have counted out, and this is the same thing. So not is valid types. No. Data type is not equal. So there is a few places where we check. Let's see. So that seems to be the last one. So we should be fine. So this says expected type pointer. So is that expected? Yeah, we don't have that in here. So is that in the backend? Is that from this? Okay, that's from the generated one. So it is not a type pointer. So where is that at? Okay, this image here. Expected type pointer. I changed that. Is that where it is? Yeah, so I'm gonna make sure that that is the error message that we're getting. Yeah, okay, so that is it. So it's from this, the external function wrapper. Let's delete it though. Okay, interesting. I would like if it did not delete it though. So let's maybe go here. Delete that, and it shouldn't delete it then. Right, so we deleted it because I don't want to be generating all this C code. If I do that, then we do have it. So okay, readWave.so.c. Expected type of pointer. So we're popping it off, and it's not a pointer type. Which one is it though? So in the init window, let's see. All right, we have a few places where it could be. So draw text. Let's maybe make it more variable. Okay, so let me move this. Let's see, and put this back. But make a more variable example. So maybe I'll just even copy stuff from here, and then I will move it to test.c, test.kano, and kind of go from there. You know. Oh, let's see. So we need close window. Window should close. Begin drawing, end drawing, clear background, and that's it. So we'll narrow it down just to that. Get rid of these keys. We still need the height. That's important. We don't need this. We don't really need set target FPS. We don't need that. Begin drawing, clear background. That. Okay. And let's try that out. Okay. So it's in one of these. That's not okay. There is a null byte. Okay. No, it should not say that. Okay, so type of pointer. So which one of these expects a pointer? Int insert. So it looks like it's gonna be this one. The init window. So that is not a type of pointer. So I think the types must be a bit messed up. Int pointer void. So did I mess it up? Let's go here. And let's maybe grab this. Let's take a look. Take a look-see. This is the wrong one. I'm going to go to here. So pointer. Right, so this got messed up somehow. Right, because we don't use doubles or anything like that. Stir, it should still be a pointer, so I don't know what that's about. Maybe we should change it, so expected type of pointer, but found. And then we can't really print out like that. We can print out the number of it. And let's just print. Okay, but I guess we can't do that exactly. Unless if we escape both of these. Well, we just escape that one, right? Or if we do that. Yeah, okay. Found, and go here and put the actual data type. Can we do that? C dot type. Let's do that. And let's maybe make a new line for this. Right, and then we can put char I plus a, and that is just to get the variable in it, right? And I messed that up because I meant to do that. Oh yeah, now I need to remove this again. But found 8. Okay, and 8 is what? So 0, 1, 2, 3, 4, 5, 6, 7, 8. So we got a U16. Why would we have a U16? What the heck? We have integers. Thinks that this is a U16. A string. Did I mess up the string? It shouldn't be. It shouldn't be. So in... Well, hang on. Let's see. We're popping it off the machine. We could even go to the gen. Right, gen the external function call. Right, can we go to the actual generation of the call? No. Well, we had this right here. So we have all the args. This is the yellow, but I want the actual call. So let's do gen. Right, so gen the expressions here. I print out all of the, right, so this is where we're doing it. So print out all of the expression types. Data types. Vector value dot x dot r dot data I Data type. Okay. Dot data. Right, if I do that, you know, doesn't like any of that. What the heck? How bad? Alright, data type size. That's not what I want. Data types like that. And I don't need the dot data. Okay. Am I missing a thing? Yeah, sure. Or okay. That needs to be an arrow. Okay. And now, if I run this, int, char. So none of those would do that. So I don't know what the issue is going to be here. Can I move this? Go here, comment that out, and look at the generated code yet again. Alright, and then, yeah, create lib.so.c, and look at that. So, do we have u8 somewhere in here? No. Alright, so we have, expect type of pointer. We found that. Right. Pointer. Do we have any other place where we would be checking for that? Ooh, we do this a bunch of times. I don't know if that might be an issue, but it should be fine. Alright, so here as well. So draw text. We don't use draw text. Wait, so why is it generating all of it? Am I running it wrong? So.c. Alright, and now look at it. Right, so we don't pointer, and that's the only place where we actually use the pointer. Okay, so it is in here. It's in the init window, and it does not recognize a string as a pointer. Okay, so that is definitely what we're looking at. You know, that's not good. So it's not recognized this as a pointer. Why? Let's put this back. I don't want that still. And this is not in the wrong order. Could make this a char star though. Let's see, that might break stuff though, so I don't actually, yeah, I want that. Because we have other reasons for doing that, and it's fine, just as a void pointer, and then we interpret it properly when we need to, right? Okay. Found 8. Let me think. Let's see. Why does it say 8 though? That's 8. Oh, you know what? Hang on. I might be stupid. I need to look in the team.h. So let's look at type. Yeah, data type is what I want. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Pointer type. That is a pointer type. Okay. Yeah, so that is where we are getting some issues from, right? Is it because this is now out of order? As pointer. Yeah, okay, that's not it. But it is a pointer type. It must be something something that we messed up somewhere. Let's look at this. So we have this map up. I have not looked at this for a while, so we pop both of them on. Look at the as type, and then I should probably wrap these in some parentheses and such. Push that there. Okay. Data type. Let's look maybe at when we are grabbing it from the stack. So what are we doing there? We are like pop. Just looking at the pop machine, right? Pop right here. No, pop. I want to look at pop. Wait, no, pop machine. It returns data. Obviously. Let's maybe print Machine stack. Well, is that even going to be useful? Actually, I don't think so. Let's maybe look at it in GDB. Could we do that? Run, that's not Dana. Can I do that? Right, it's calling all these things. So can I break, we don't get to running instruction, right? Yeah, okay, it does get to that point, alright. So it's when we're calling it. So yeah, then we can look at what's on this stack. That will be useful. So we push string, right? This is all the things that we're loading. So these should be fine. We should be able to get through all of these fine. Or load them and all that stuff. Stir, and this is, yeah, so this is close window. But then it's when we actually call them that we get some issues, right? Quite a few of these. Begin drawing. Alright, so I think that might be the last one. Yeah, okay, so now we're actually loading like name. So begin drawing. So we call begin drawing, and that's fine. There is no arguments to that. So that works out. That works out fine. And then, so now we're pushing a string onto the stack. Is the memory type, or is the type of this messed up? It doesn't look like it's gonna be. Alright, I'm gonna be right back. Quick break. Just give me about 3 minutes, and I will be back. Okay, I'm back. So yeah, let's keep going. So we have we're pushing another string. Alright, so this is actually another one, so that's fine. Is more and drawing. So that was kind of weird. We loaded one, but now we're pushing another one. And let me quit out of here. And let's look at let me test that here. That's kind of weird. Why it called it? Because it did, right? Or am I going crazy? Yes, we do load it. Oh yeah, we're just loading it in there. Okay, I'm stupid. Sorry. Yeah. Stir. So this after end drawing, what did we have? Clear back. All right, so this is actually the last one. So we just have to load 2 of those. And then we actually load the that, and this should be done. So now we're pushing print machine dot instruction data ID and print all of that. Nope. Machine dot instructions dot data IP. Okay. So it's 800 as all right. So that is an integer type. Yeah. So that should be all right. As an integer. Okay, and then the next one, we're pushing it, and let's print the same thing. Machine.instructions data IP is all right. So it is another int type, and it's 1000. So that makes sense. So that lines up with what we have here. So we're pushing those, and then we're actually going to use them, right? So stack side, yeah, and then we're going to duplicate them, so we push a value, and then we're going to subtract. So this is just basically grabbing it from the stack. I mean, dupe, and we do it yet again for the next one, and then we actually push a string for the next thing. And dupe and push string. Okay, print stir. So do we get messed up from this, right? Because this should be a pointer type. Pointer type. My chair is squeaky, by the way. That's not something else. And so we get the index and we print the string, and the string is correct. The length, that looks like it's going to be correct as well. So does it not push it to the stack properly? Right, it looks like it would. And frick. I just messed it up bad because it just exited. So yeah, we don't have that anymore. It did exit there when we opened it. But we didn't even call it yet. Okay, well let's go through it again. Go through all this. Okay. Go here. So we're gonna go through a few times. And we'll keep going until we get out of these push stirs, right? I'm not sure how this looks in the recording, but okay. Print stir. So what is it? Begin drawing. Okay, so we're almost there. So we have 2 more. All right, so this one, and then this is the last one. It should be. So we're gonna load it. Make sure. Yeah, we're back. Okay. So now we go here. We load the library, yes, and then we go back through here. So this is pushing the values, and then we're going to actually get the values from the stack. And once we get to the push string, we have to look at that. Sub and then dupe. Push string. Okay. Print stir, right? So we have that, and that should be fine. But then when we pop it off, it is wrong. Print machine.stack. Machine.stack size. Machine.stack size. Print machine.stack size minus 1. And it's a pointer type, so that is correct. Hang on, is something messed up in... Actually, now I'm thinking about it. Is that going to get messed up? Okay, I will come back to that. I had a thought. Let's go here. And right when we load it, it's going to fail. Okay, so it did fail there. Let's see, I don't have the C code. Let's grab it again, because I want to look at it. Right. That's not fail. Okay, and look at this. If it does not equal pointer type, then expect type of pointer, but found that. I make it that. Where I print out both of them. Expected type. No. Expected type. Type that. Let's do it like that again, you know? So set D, and then, oops. Then we can get rid of this whole thing. So that type, and we put that. 3 of them, and func.others.data on. Okay, so do it like that, and I think that should work. Just want to run this and make sure it does. Does not. Okay. Expects an argument. So why is this not work? Send S type. And we do have that, right? So what is this? Expected that before C. Okay, let me look at what it actually did. Oh, I forgot a comma. Okay. Volcano, and then we type 3. Okay, so now we are getting somewhere, right? And I know exactly what it is. Okay. I am so very much stupid. So dot C. I want to delete it again. Oh, it is. Alright. Okay. Yeah, I forgot to change it here again. So user include. We need to do that. No. Sudo bin tnh. Okay. And if we go here now, we can actually fix this. So what is this about? Okay, I don't know. The tabs are a little weird. But yeah, we don't have all the data types here, so that is what the issue was. We need to add basically update all of these. Basically need to update the whole thing. Right, and that's unfortunate. Right, so I don't want it to actually be like this. So that is another thing with what I was trying to do. So maybe I'm trying to think, right? Okay, I'll just update it for now. So we have pointer type, we have U8 type, U16 type, U32 type, U64 type. Yeah, I'm kind of double type. Okay, we have that, and then we have uint. Oops, and I don't know why it's not working right. Uint 8 as U8. We have a few of these. 16, 2, and 64. There we go. So we got that, and then we have the and we have float as float. Okay. Let's see. That might cause some other issues, but let me try that. Right. So I shouldn't actually have to recompile anything. That's not here. Run that. So type 4. Okay, type 4. 0, 1, 2, 3, 4. Pointer type, but found 8. So it must be in the wrong order. Actually, I must have messed that up. Let's actually, let's go back to the source. Let's dot 8, and let's go to data. I put it, I seem to have put it incorrectly. So let's grab all of these. Whoops. No, that's not right. Grab all of these, and they go right after the int type. Float type, double type. Okay. So now we compile it. Let's go here actually. Let's run. That's not cleaning. And it does okay. It does work. Thank goodness. Alright, so I had to update some stuff there. That is fine. That is fine. So can I run the regular Kano now? With all the extra stuff. Okay. The arrows do not load. Because I actually got rid of them, didn't I? Yes. I did, yes. Okay. But it does load everything, and we have the types now. So that is a major relief. So I'll probably commit that. Right, so again, there's an issue with this. I did not like that. So I'm going to definitely change how it works. Where I'm gonna... Well, I guess I could have it install along with it, but there's some other things that kind of it depends on and things like that. So I'll think about that for sure. But yeah, I'll get rid of that. I will work on that. Implement support for U8, U16, U32, U64, and double types. But we really already had the double types. So now it's more the float types, which I guess I did not really check if there is problems with that. But something I can do now. So if I go ahead and do this, and we do have is key down. Is key down. So all of these ints should really be in 32. And I wonder if that's going to break stuff, you know? U32. Well, okay. They're really not U32s, are they? They're I32s, right? So maybe I need to implement support for those. But let me try this, right? Let me change it to one that we're using currently. Let's see. Actually, what does that use? So let me look at Raylib.h, and let's look at init. I think we just use a regular int, right? Yeah. Okay. So let me try U32 because that is the closest that we have. Okay. And height is 32 and 32. Okay, and will that work? Type 3, but found 0. Okay, so it does not work. Wait a minute. That is interesting. Okay, because we're taking the types directly. That's not great. Because we should be able to pass some of those. Well, maybe that could just be casting, right? We could use casting for that. But, why does it think it is? Why does it think it's a regular integer? You know? Because this, it should become a U32, not that. That doesn't even work. What the heck? So the both of the types must not be very good. Right, because that, yeah, so it thinks it's that. That's not good. So something to do with variable declaration. So let's go to here, right, and let's do deck perhaps. But we don't parse the expression yet here, and we set the type equal to. Yeah, we set the type equal to that. Okay, but then we have the expression, and we need to set the expression type equal to the proper one. So after we call parse var deck, we want to basically cast it essentially. Deck. Okay, and here's what we're doing that. So we have a few things here. Where do we parse the expression, right? So that's if it's an array. We don't care about that at the moment. Else, do this. So we append the parse expression. So let's instead, let's set expr equals parse expr parser. And let's check this. Well, okay, yeah, we can just check. We can change it like that. So if that is wrong, otherwise we want to set node value var type data 0 data type equals node value var type. So I want to make sure they are the correct data type, right? Okay, no. Dang, okay, it still did not work. What the heck? Right, so we're changing the data type essentially of the expression. We don't support compiling to that data type, do we? Oh shoot. Okay. Yeah. So we need to change that in the backend.c, right? We have gen expr. Where's the actual gen expr? Okay, right here. So expr int, and we push it like that. But I want to push it right, based on that as well. Okay. So we need expr u8, expr. Okay, we need all of those. Well, okay. Let me think. Right, because we do this. We should just pass the type here as well, shouldn't we, though? Right. Well, let's make gen push u. Let's do underscore u. And then we'll have u int 64t value, and as u64. And let's pass the type to this. Let's do type. And we'll use the type here, you know? Okay, but actually we need not the type. It's not type in, it's in type. It's the type from the virtual machine. Data type. So I think we have a way to get the correct data type. But yes, we'll do this. Right. Because then we can push the correct type. So gen push u. Gen push actually. Well, okay. Gen expr. I want to go to the actual gen expr. And expr int. We could look at the value of the data type value. So let's maybe switch over expr data type. And let's do case type int, and we'll do this, right? Case type u8, type u64. That's not right. U32, and then u64. I'd rather have it aligned properly. Then we can gen push u, right? Gen, and we need break as well. Gen push u and pass that. Still value.integer, but then we want the type to be. Let's do type. Do data. Type to data, and we'll just put the extra data type. And will that actually compile? I'm not sure. So those are not handled. Let's just add a default and assert false. Let me check. Okay. So type 2 data is great, but that's the only problem we have. So let's make a type 2 data, right? Is it gonna be that? No, it's gonna be a type. So let's do data. Type 2 data. Data equals, and we're gonna put all of these in here, but we're going to change it to the correct thing. So we need int type, type, and then this is gonna be incorrect. So let's just set it. We'll set it to that. That's fine. Type. I think this is correct. Float type. Okay. Type. 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 And that is not correct. I can see actually. Type u8. So I did all those backwards. Type u16. Type u32. Type u64. Look at those. Type double. Oh shit, I believe it's 0, but I need that. Which is just an int type, which that's just a way of showing programmatically that it is not correct, right? I'm missing a semicolon. Okay. Implicit conversion, interesting. So do we not recognize data type? So do have data types. Is that not how they are set up, right? Data. Shoot. Okay. It was right the first time. I am. Alright. I don't like that it doesn't use tabs, and that makes it very inconsistent. Yeah, because I was not using tabs before when I started this, but then I switched over to tabs, so. Alright. Yeah. Definitely need some sort of multi-cursor-esque thing in Kano. Because that would make this a lot nicer to do. Okay. And that does compile. So, was that everything I needed to do? I don't remember exactly. Okay, it looks like that. Did that actually work? Okay. Wait. Oh shit, I ran the wrong one. Okay, I'm stupid. It did work though. Okay. So Kano. So now we set it to that, and it recognized the correct type. But if we make this an integer, right, it's gonna complain. Well, actually, it'll probably complain on the compiler level, right? I guess it will not. Okay, it really should. We should probably check that for sure. Well, no, okay, because it checks any int. Yeah, we don't check it in there. So I'll need to. Ooh, I guess on that one we need to be very precise about which ones. But then it's gonna cause issues. So that's kind of, I don't know. That's just kind of a headache thing that I will figure out how to do. But just add a function to check the types in the same way that we do here. So I'll do that. But yeah, so it needs to be the correct type. That is fine. It's really annoying with that kind of error message. I don't like it, but I'll make it better, you know? working on. So that works now. So U32 does work in that way. And in it, we know I don't, that actually returns void, so we don't get that. Close window returns void. Window should close does return, but can we make it return a U8? And then, so this should change that, does it? Actually, maybe it won't. Okay, unknown type name U16. So that is something. So we need a bunch of type defs for that. So we do have these. Let's add type defs for all of it. Let's do uint 8t, uint 16t, uint 32t, and one more for 64t. And we can do u64, 32, 16, and u8. Okay. And then I need to remove this again. When it crashes like that, I should make it delete the file, but it did not recommend. So, okay, we get a bunch of unused primitives, but that's fine. And it looks like it did work. So that is good. And now, I want to try it with the is key down, right? So is key down takes a regular integer. Well, we'll make it a u32 perhaps, and it returns u8 because whoops, u8 because it really returns a boolean, right? We should be able to compare it to that. So let's do if is key down key right, then wait, can I just check that though? I think I can. So I do that. Then we just draw the rectangle. So rec x is rec x plus 1 and x type that but found 0. Okay. So we need yeah. See, this is where it gets really annoying because we can't just check it like that. We need to actually create a U8. So let's do comparison U8 equals 0. Compare it to comparison. Right. If we had a way to cast, we could also do that a bit nicer. Type 3 but found type 0. Okay, so why is it finding type 0? Okay, because key right needs to be a 52. Okay, it still says that. What the heck? Oh, well, we don't do this, first of all. That is incorrect. I still, type 3. So which one is type 3? 0, 1, 2, 3. So U32. So it is something with that. Do this as well. Right, I don't like all these things. Yeah, okay, it doesn't recognize the keys though. Okay, now that is always true, so is key down. Right, I don't remember how it worked. So we want to check if it was 0, right? Or no, we want to check if it's 1. Equals found. Okay, so it does it not work with this, with the U8? It should though. Right, which one is that type? Key right. Turns a U8. Right, and that's going to be always true. Okay, quite an issue. Okay, yes, we didn't quite fix the issues that I was planning on fixing. And I just go pretty soon, but let's see, so could it be another issue? Like, okay, we check is key down. Do something like that. those should both be U8s. So let's see. Hmm. Yeah. Let me think here. So I was thinking about something else as well. So I was thinking here, right? When we delete the files at the end, we just loop over them all again, and we check if it exists. We could also we could do the same thing for the object file, and then just compile it once here and load it all at once. And that might be a nice thing to do, right? In terms of then we won't get the same error message over and over again like we do there, or the warning messages, right? That would be nice. That would be nice. Right. Right, because we get them over and over again, because we compile them over and over again for each of the things. Let's key down, key right. UH should be 1 byte as well. Could be something with the comparison though. Hang on, let me think. Yeah, so comparison, right? So it's compare. Yeah, we compare them both as U64 though. But that, yeah, it shouldn't be the cause of any issues. Because they're both gonna be the same. I said now UA equals use then check if val equals com. Like that should work. Okay, and let me look at this. So which one is that failing for? It's for the close window. Why does that fail? Okay, because we don't use machine at all when it's void. That makes sense actually. Right, okay. Yeah, that's not, I'm not gonna worry about that at the moment. Why does this not work though? Key right, that is correct. Bum. Turns a U8. So this is a U8. We compare them, they're not equal. Okay. Yeah, that's gonna be something I'm gonna have to look into more. I thought this would fix it since they are both 1 byte, but it seems it might be harder than that as well. It could be something with this as well, because that is not the correct type, right? So I'm not sure. But yeah, I'll look into it. I do have to go now. So let me commit this. Push that. Alright, there's actually a lot of insertions, but okay. Did I actually leave? Yes, I left a folder in here. A directory rather. It seems not. Well, okay, yeah. So it should be okay. So yeah, that's gonna be about it for today. So thank you guys for watching, and I'll see you guys next time. Goodbye.